Okay, as we are going through these practice problems, I do want to just kind of skip through like I did question 1, okay, great, but question 2, not a whole lot different. Horizontal toss, given the height, distance away, all that good stuff. The only difference in 2 is it's saying the target is 50 meters away, and the idea is that when Joe Namath fires the arrow, we know it's going to land short. He literally aims directly at the bullseye and doesn't account for the fact that gravity is going to pull it down. So, good job, Joe. What's going to happen is you're going to solve for t first, just like you did in question 1. You're going to plug that t into the x equation because you solved the y equation to find t. You're going to plug it into the x. You're going to find how far it traveled in the x direction. But you're not going to box that in as your answer. It is asking how far short of the target does it strike. So what you need to do is take the answer from plugging into the x equation and subtract that from 50, because I guarantee your answer is going to be less than 50 when you solve in the x equation. Take the difference between 50 and your answer in the x equation, and that is the answer to the question, how far short of the target does it strike the ground? Anyways, the equation is the same, process is the same, just asked a little bit different. Same thing, question 3. 3 is actually really similar to 1. It's saying you are 5 feet off the ground, the ball is 5 feet off the ground, traveling 90 miles an hour. How far away from the player does it hit the ground? Well, frankly, the only difference between question 1, throwing a football horizontally, and throwing a baseball, the only thing is your units. Please pay attention. This is given as 5 feet above the ground. My units in my horizontal velocity, though, my v sub 0, is in miles per hour. My gravity unit is going to be the negative 16 t squared. The problem is that is feet per second squared. So in other words, you need to get 90 miles per hour into feet per second. Yeah. We need feet per second. But, okay, of course, thanks to Google, you can just say, hey, 90 miles per hour to feet per second, boom, 90 miles an hour is 132 feet per second. And all you need to do is kind of do one of these like there, and it's 132. And then you still do the same as you did for question 1. Question 4, also the same as question 1. I have a video on that, except this guy is, why would you do this? Throwing a watermelon straight out of a 3rd-story window. I don't understand. You don't need to understand. All we need to know is we're trying to figure out how far from the base of the building does a watermelon land. We should be asking ourselves, why is he doing this? But because it's a math class, we don't ask questions. We just answer the ones given. So you plug in the equation, initial velocity, straight horizontal, your x is just going to be 10t, your h sub 0 is 45 feet, all that good stuff. These are also really tall stories. Typically, one story of a building is about 10 feet. So if he's throwing it out the window of his 3rd story, he's not even 30 feet, supposedly. I mean, because he's in the middle of the 3rd story. I'm guessing this should be closer to like 25 or 30 feet, but what's the excitement in that? Anyways, question 4 is the same. I digress because I'm really trying to do question 5. Question 5 is pretty different. I'm going to say, first of all, a person standing on a cliff throwing a stone horizontally. Here's the difference. We're given the horizontal velocity, but we now know how far from the base of the cliff it lands. What we don't know is how high the cliff is. The first thing I want you to do is take this right here and scribble it out. There is no reason to do trial and error. We can do the exact answer. Here's how we do it. We're going to go to our blank sheet of paper, because this might be enough room for you guys, but again, because I'm doing this on my screen with this really bulky like stylus pen thing, I'm going to use more room. So what we do need to keep in mind, though, as I transition to my worksheet here is 19 meters per second, and it hits the ground 60 meters from the base. All right, so question 5. We don't know, we know our v sub 0. Okay, and we do know alpha. Alpha, because he's launching this straight horizontally, is 0 degrees. Now, I can't call it h sub 0, and I don't know how long it is. So, like, we know 60 meters. It is meters, right? Yeah, it is metric. So we know that, but wait, I don't really know where to put that in the known values. So we're just going to start the equations. So I'm going to go back to blue for that. I'm going to say the equation x of t is the initial velocity 19 times cosine of 0 times t, which really just comes down to 19t. In the y, what did I use last time? I'll use that one. Similar but not. Okay, so the y. So here's where it's a little different. We don't know the initial height. So the y equation does simplify, but we still have to keep h naught. The 19 sine 0, that all goes away. So h naught minus 4.9 t squared, and that is y of t. And this is x of t. So here's the deal. We know one other piece of information. We know that at some amount of time, this thing lands 60 meters from the base. So kind of like the whole, like, hey, at height 0, when typically we set this to 0 equals da da da. Well, we can't do that because we don't know enough information. We still have 2 variables. But what we are aware of is that the end value, x of some time, we don't know the time, but we know that at some point this thing lands 60 meters away. And it lands 60 meters away by traveling at 19 meters per second for some amount of time. So we can find that 60 over 19 equals t, which equals roughly 3.16 seconds. Because again, you guys, we know that the horizontal is not affected by gravity or anything like that. We just know that after some amount of time, this thing has gone 60 meters horizontally. So now we realize that, hey, after 3 and 0.16 seconds, we have reached the horizontal. What we know, though, is that in the same amount of time it took to go 60 meters horizontally, we need to have traveled from wherever we're at to the ground. So, in other words, we know that after t equals 3.16 seconds, so if we plug it in, watch this, I'm going to say here, I'm going to write it out and then explain it. We know that after 3.16 seconds of time, we have reached the ground. Because we know that it took 60 meters horizontally to reach the ground. We know that it took 3 seconds to do that. So we're working our way backwards. But if we know that it took 3 seconds to go horizontally and hit the ground 60 meters away, we know that it took that same amount of time to reach y is 0. We have now simultaneously solved the y variable here to be 0. And at the same time, we did that by finding the t was 3.16 seconds. We now have one equation, one unknown. We're going to throw everything to one side, except the h naught is 4.9. Plug and chug, and you find 48.9 meters is your answer. So that, everybody, is your answer. So there you have it. That's your answer. Let's go back. It is asking that, so that's 19t, and that's h naught minus 4.9 t squared, but the height of the cliff, the nearest meter, 48.9, that is a 49 meter tall cliff. So again, I just wanted to do that example because again, I don't like that. It's like, oh, trial and error. Okay, well, I could show you that, and that just involves going to the calculator and messing around with some numbers and seeing what you get, but that's really like probably one of the dumbest ways to do things is trial and error. So there you go. There's our problem. I'll move on. I'll probably try and do at least one more where the projectile is not horizontally launched. It'll be actually at an angle, and we'll be good to go. So thanks for listening. We'll see you in the next video.